Now, let's make it more realistic. As you can see, we have two sides. The side of router 1 and the side of router 2. Not only that, assuming this is the internet, we don't really use private networks routing from one side to the other. And we're gonna fix this. So first, I'm gonna remove all of these lines. We're gonna make it clean. Also, we're gonna remove router 3 because this router 3 is supposed to be the internet with service provider routers. Also, this network is a private network. We don't normally use private networks in the internet. Okay, we're gonna keep the interfaces of router 1 and router 2, as well as the private networks, the LAN network. Okay. Also, instead of just one router 3, we're going to add service provider 1, service provider routers. There, service provider 2. So this is our internet. There. Okay, so this is the internet. And as you can see, we can have more routers in between because it's all meshed. There. Now, since we don't have router 3 anymore, we can remove these already. Okay? This is gone. What else? What we need is a public IP address. Okay? If you send traffic to the internet, the service provider 1 router will be the first to check if your source and destination IP address are valid. So what do you mean valid? So I'm gonna add 100.110.0/30, for example. This is .2. This network is a public network. Okay, I'm also gonna add another public network on the router 2 side, 200.200.20.0. Let's say /30. This is .1. Okay, so here's what's gonna happen. If PCA sends traffic to any destination in the internet, or in this case to server C or server D, we know that it will first forward the traffic to R1. Okay, if it's find the destination, it will forward it to the next hop router, which is in this case service provider 1 router. But here's the problem. We are using private IP address. If the service provider 1 router sees that our source is private IP address and the destination also is a private IP address, this will be dropped. So this means what we were doing is not a real life networking scenario. Okay, what we need in order for us to use a public IP address is to translate our private IP address to a public IP address, and this is what we call the network address translation, or NAT. And there are many different types of NAT, but the most simple is the port address translation, okay, or sometimes we call it PAT or NAT overload. Basically, whenever PCA or PCB sends the traffic, it will use this IP address, the IP address of router 1 interface. Okay, so 100.100.10.1, this is now the IP address used by PCA. And if it's route towards router 2, router 2 will see, oh, you are using a source of 10. Excuse me, not 10. You are now using, or your source IP address is 100.100.10.1. Okay, so on the router 2 perspective, this is what PCA is using. But we have other problems. First, the destination cannot be this, okay? Because this is a private IP address. So let me add here NAT, where our source IP address now is 100.100.10.1. Okay, now we're going to use the same on router 2. We're going to enable NAT or NAT overload. Our new source IP address will be 200.200.20.1. 20.2. So in the case of server C, if it needs to communicate with other networks or a public website, it will send to R2, and then the source of server C is now this IP address, because we're using translation. We're using the IP address of these router 2 interface. Okay, but we still have another problem. As you can see, this is internet, right? This is internet. If this is internet, our router 1 and router 2 will be using a different routing. I'm gonna remove this second static route. This second static route. Also this one. And then I'm gonna modify these. We only need one static route. And this is what we call the default route. Our default route should be not a specific network, but to many different networks. As a matter of fact, default route means all other networks. So the configuration would be 0.0.0/0, and the next hop would be, let's be specific, we'll use this next hop IP address, which is 100.100.10.2. Okay, so what I'm gonna do is I'm gonna add a default route 0.0.0.0/0. Okay, and this is forwarded towards interface E2 of router 1. We're going to also add that default route on R2 side, 0.0.0/0, and then the next hop IP address will be this IP address, 200.200.20.1. Now, here's what's gonna happen. All other website, all other network, and since this is the internet, we can add many different websites and applications. Okay, this can be banking, this can be gaming, search engine, any other publicly available apps or website. What will happen here is, if PCB, let's use PCB now. If PCB sends traffic to any applications available in the internet, it will forward it to the default gateway, router 1, and router 1, regardless of their public network. I will just forward it to the next hop router, which is the service provider 1. Service provider 1 is this. And the service provider 1 router will just forward it to the destination. Of course, this is processed by multiple routers on the entire internet, not just one service provider, but multiple service providers as well. All right, one thing that I need to point out is that PCA and PCB, they cannot just easily forward the traffic to server C and server D. We need to have a static NAT. A static NAT. And the static NAT is a one-to-one mapping, meaning server C, it will have a dedicated public IP address. Okay, and all right, so here's what we're gonna do. Instead of /30, we're gonna use /24, for example. Okay, and we're gonna add a static NAT where we are mapping 20.3, which is the server 3 IP address, to 200.200.20.20. So this is the IP address of server C. And we can add more public IP address for other servers, such as server D. We can add, if it's 20.4, we're gonna map it to 200.20. All right, let me just fix this. All right, Okay, so for server C with an IP address of 192.168.20.3, it is mapped to 200.200.20. Let's say 21. Now, for server D, it is mapped to 200.200.20.22. There you go. So for PCA to reach server C, it needs to send traffic to this destination, 200.200.20.2, and the router 2 will forward it to server C. Now, if PCB, this is PCB, if it needs to send traffic to server D, it needs to send to 200.200.20.22. This IP address, and router 2 will just forward it to server D. It cannot send directly to 192.168.20.0 because it's a private network. In this example, this side, PCA and PCB side, we need to enable NAT overload or port address translation. While this side, server C and server D side, we need to enable static NAT.